Good morning, good afternoon, or wherever you may be. Possibly it's even good evening. Thank you for your interest in our webinar today hosted by Impetus Technologies on the topic of NoSQL Landscape and a solution to polyglot persistence. This is actually a recorded version of the webinar we delivered on May 9th. My name is Larry Pearson. I'm the Vice President of Marketing at Impetus. And joining me today as our subject matter experts are Vivek Mishra and Chavi Gangwal. And Vivek and Chavi are both architects who specialize in big data and specifically NoSQL technologies from our Impetus Labs team. So let's take a look at our agenda for today's session. What we'll plan to do is give you a survey of the NoSQL landscape and talk about the differences between the RDMS world in which we've all lived for a long time and the NoSQL world as it exists today. What are some of the challenges as we move from that legacy relational database management environment to NoSQL? What are some of the tools available in the NoSQL world? And then specifically to introduce an open source polyglot solution which has been open sourced by Impetus Technologies, which we call Kundera. So with that, let's go ahead and jump right into our topic. And the first thing is what we call the big data problem. And what you see here really is a giant elephant made up of various considerations, very familiar to those of you who operate in the big data world: variety, velocity, availability, scalability, etc. So the big data applications opportunity today really needs to consider many of these. One of the first questions that may be on your mind is, okay, you know, what's this whole NoSQL thing all about, and why can't we perform these same functions in the same way using a relational database management system? RDBMSs have been dominating application development for more than 30 years. So let's go ahead and look now at some of those considerations which fall largely into three areas: scalability, data formats, and availability. With regard to data volume, the big data volumes today can be petabyte scale or larger, often providing challenges for low latency processing of queries against relational database environments where you may need to actually join different tables and so forth, which across many tables and large data volumes can be a performance challenge. Data distribution, when data is stored or queried across multiple geographical locations. Scalability, it can be very expensive to add server and licensing when needing to provide massive scale to provide new big data applications, or to support new big data applications. Data co-location in today's global environment, replication can be a challenge across geographically distributed data centers and locations. Related data should be located as often as possible on the same node, and that's another challenge in today's globally distributed high availability environment. And lastly, data format, where data can be structured, semi-structured, or unstructured. Examples here would be server logs, archive data, network data, or network logs. So, if some or all of this is not best addressed through the RDBMS approach, let's now look at some of the key features of the advanced solutions that are available today to better address these. And they fall into, again, a handful of important categories. So the first one that you'll see here is the whole matter of scaling up versus scaling out. And the non-RDBMS options allow for adding more data nodes, which are less costly today than simply adding more resources to the existing infrastructure. The second area would be the issue of static versus dynamic schema. Data and its format may vary for each row. So a schemaless solution offers an advantage here over predefined data store formats. Lastly, centralized versus decentralized servers. Adding a few database machines into the existing relational database configuration is obviously possible, but not necessarily the best solution since in the big data world you may need to add hundreds of data nodes, and that can be very expensive. The data also needs to be highly available with minimal or no downtime. So those are just three areas which show some differences that the new data structures offer, where they offer distinct advantages. And now let's take this whole NoSQL topic and look more deeply at that. NoSQL is defined as an approach to storing and retrieving data with horizontal scaling, simple design, and high availability. And it does often require those of us who've grown up in this RDBMS world to think differently. It may come across as somewhat unconventional when we talk about normalized versus denormalized data structures, etc. And breaking with some of the historical rules of RDBMS. It allows us to select a storage mechanism to meet specific and varying data processing requirements of different applications and use cases. So depending on the structure or format of the data, which may be random, selecting a data store and implementing that based specifically on the different data formats offers distinct advantages. Data availability can be ensured by automatic replication across multiple nodes, ensuring no single point of failure results in any loss of data. So here again are some of the high-level distinctions where NoSQL brings some advantages. Digging deeper into that, how more specifically do the NoSQL solutions address data availability, consistency, and things like partition tolerance? And we'll now jump in and look at each of those in some more detail. And to understand that, let's just take a little look back in time. It was early 2000 when Eric Brewer introduced the CAP theorem for distributed systems. And according to this theorem, none of the databases would fully address all three at once: consistency, availability, and partition tolerance. So the intersection that you see here in the center of this slide is not practically addressable or fully addressable in today's real-world scenario. So based on the processing requirements for any given application, we will tend to focus on addressing or optimizing around any two of these. Most SQL databases advocate for high availability and partition tolerance with eventual consistency. And this is some of the change now that you're going to see comes into focus on those requirements most important for each application or each use case, and the fact that we have different options now to fine-tune the data store to that. So in thinking about NoSQL, one of the next big questions that you may be asking is, when should I start looking at NoSQL? And what are some examples of some use cases that might help elaborate that? And an example of those, streaming online data, analyzing behavioral trends from data collected over the web, creating email filters and having some sophisticated logic to deal with that, analyzing data for fraud detection in real time or near real time, performing historical or other kinds of custom analyses on captured data, and then finding out and tracking social media trends in near real time and being able to offer timely recommendations on that basis. So these are just some of the examples that fall into the category which are commonly better addressed by NoSQL solutions. And let's dig into that, drill into that even a little bit further by taking some examples and discussing various important factors that you would normally want to consider before adopting NoSQL. And NoSQL problem statements can be categorized into the following. And the first is size. We talked about this a little bit earlier when we talked about volume, variety, or volume, velocity, and variety. And data size today is often beyond petabyte scale, and is growing especially due to the concern over wanting to leverage unstructured data or data in real time. One of the use cases we've worked with recently was an equipment manufacturer that manufactured escalator, elevator, and then also closed-circuit TV equipment to monitor those people-moving facilities. And they forecasted an expected growth in data volume by 50% over the next 2 years, and it was easily forecast to reach exabyte or a larger scale. There was a need to perform real-time analysis over footpath count and pattern analysis over traffic across their equipment, but also in the area, including passerbys who may have opted not to utilize their facilities. So that's one use case, one example. The next area is the whole area of velocity and the need to process data in near real time and apply advanced streaming data analytics to data in motion. Parallel calls for parallel processing and a ready for read design. And here again, traditional relational database structures are not fast enough to meet the kinds of SLAs that would be required in that environment. Another example of a company that we have worked with recently, a satellite communications company actually based in Europe that provided cable and internet service to their multi-millions of customers. And they had the need to perform near real-time analytics on large data analytics over archived data logs. They also need to analyze customer views and choices based on various demographic groupings as a way to create preferences and do various demographic analysis of programming. So the next area, so that covers the area of volume and velocity. Let's look now at the variety issue. In different non-relational data formats can literally present a scenario where each data set is different and may require graph-based or key-value-based access. We'll talk more about the different categories of NoSQL solutions here shortly. An example here was a credit card provider who was collecting data from a variety of input sources, including social media, web logs, and et cetera, and wanting to perform sentiment and behavioral analysis over that. In this case, it did require a combination of key value and graph-based access and representation for analyzing end-user information, session management, etc. The next area we would look at is the area of the need for advanced filtering. This is typically a requirement in the many industries that need fraud detection and fraud analytics and other risk management analyses. In the case of a bank that we're working with that had both credit card and mortgage approval applications for end users, they were required to provide fraud detection over very, very large velocity and large customer database. He had both the volume and velocity issue to deal with, and to be able to analyze credit history and perform OLAP processing across that. Well, those are 4 examples of where volume, velocity, variety, and the need for advanced analytics, real-time processing, and various levels of filtering are much better suited by the NoSQL solutions than they would be in an RDBMS world. Having established then the environment where NoSQL was designed to provide meaningful solutions, let's look further at that NoSQL landscape. Today there are more than 150 different NoSQL database solutions. In fact, it's difficult to even list them all. Certainly on this page we have just a handful of some of the most popular NoSQL databases. You may be familiar with many of them listed here. And we've talked about the problem. There's a huge array of solutions. Let's look now more closely at some of the things that you'll want to be looking at as you look at developing a NoSQL strategy. So what are the options that I have? How do I select one of those? And in this environment, are there any available APIs that will make using these simpler? And I don't mind admitting that that's a little bit of a setup for our discussion about some of the tools, and in particular the Kundera product and how it helps to do that. And what if my application requirements are actually better suited for a combination of data stores, and that no one data store is a best fit across a variety of use cases, even related use cases. So to help better answer these, I'd now like to invite one of our subject matter experts, Vivek Mishra, who I had mentioned earlier, to jump in and elaborate all of this. Vivek, again, is an architect in our Big Data Lab. He is also the author of the Apache Cassandra for Developers Guide, and will, for those of you who stayed through the full webinar, will give you an opportunity to request a free copy of the ebook version of that at the end of our webinar. He's an expert in NoSQL, and let me now introduce Vivek Mishra. Vivek?
Thank you, Larry. A very good morning, good evening to all our audience today. Next comes the most interesting part. How do I select a NoSQL from the options available in this NoSQL landscape? Since each data store is designed with a unique set of characteristics and capability to address a particular problem that can be categorized based on their type and usage. Let's try to categorize these databases. First in category is graph database. A graph database uses graph structure like nodes, edges, properties to represent the stored data. This means each node is adjacent is a point to its adjacent nodes, and actually no index lookups are necessary. In real world, you can compare nodes to entities like employees, order, products, and these graph databases are a powerful tool for graph-like queries. For example, computing shortest path between two chosen nodes. Graph databases are ideally suited for social applications, and that replicate graph-like structure among people, but they have applications in domains which ranges from product engineering, assembly line to operational research. Let's explore graph-like databases with the help of some queries which are actually best fit for graph databases. Like what music do my friends like? Something which I don't own. What about, let's say, power supply goes down? What about the web services? How many of my friends of friends are interested in a certain product that I have liked and shared with my immediate friends? So basically, this is where we are talking about building in hierarchy. So few of the popular ones are Neo4j, Titan, Objectivity, OrientDB, and VertexDB. Second in the list, we have columnar database or column-oriented database. So these are actually can be thought of as a combination of NoSQL and RDBMS word. Databases such as Cassandra, HBase, they do provide support for a table-like structure, but the catch is the columns within a table for each row may evolve or can be edited at runtime. That said, schema can be fixed or evolving. Let's discuss some possible use cases for these kind of database. And that they could be like storing and querying transactional logs, analyzing time series data, building a messaging platform, or like implementing a recommendation or filtering based system. Few of the popular ones are Cassandra, HBase, Hypertable, and Bigtable. Third in the category, we have key value. So actually, key value databases are totally schema-less databases. What we have is a key and a value. Keys and values are allowed to be of any data type available in underlying programming language. The way the data is stored is opaque to database itself. It doesn't care whether my data is XML, JSON, plain text, or even an image. So key value data stores move responsibility of understanding how data is stored from database to application itself, the application which is responsible for handling, reading, and writing the data. Actually, big table inspired databases like Cassandra, they do have this concept of key value pair, but up to some extent. So we can say there is an overlapping of boundaries between the two. As a result, the point is there is no need of a fixed data model. Few of the popular ones are Oracle KB, Redis, CouchDB, and RIA. And the last category is document-based storage. The basic idea behind document-based storage is the document that can contain data in some format and encoding. A wide range of encodings can be thought of like JSON, XML, JSON, YAML, PDF, MS formats. So basically, each record in a document-based table has a key and a document. So a collection of these documents is actually what is termed as collection. So the two most popular ones are MongoDB and Couchbase. And a document can also be thought of as a list of documents. That is what is called embedded document. The next is, what about high-level APIs? Lenny, what do you think?
Well, some of our audience may be thinking at this point about actually designing and implementing a system based on NoSQL. And this whole idea of having such a wide variety of solutions, maybe even needing multiple different solutions, it seems that developers may need to learn different APIs across that landscape, and that could be a lot of work. It could introduce a learning curve risk. Vivek, what are your thoughts on that?
Yeah, sure. So talking about high-level Java APIs, let's discuss about these high-level Java APIs based on their categories. So here we will be discussing about high-level Java APIs for a few popular ones. For example, for Cassandra, the options are Hector, Easy Cassandra, Nginx. For MongoDB, Morphia, Data Nucleus, Spring Data. For Neo4j or graph-based Spring Data, Hibernate OGM. And similarly, there are APIs for Edgebase as well, so which includes Spring Data, RobScript API or Edgebase Java APIs. But the question is, does this mean to use more than one database in my system, I need to use a different API for each database? And in order to do so, do I need to learn each one of them? Honestly, that's a lot of work. To solve this problem, Impetus Labs team developed an open source initiative called Kundera, which actually supports all of these data stores. And the point is, it can be thought of as a one-stop solution for all the technical challenges which we have just discussed. To summarize, basically, we are talking about multiple use cases within a use case. Obviously, that comes up with multiple challenges. Right. So, having discussed about NoSQL available technology landscape, which consists of ever-growing list of databases, one thing is pretty clear that each category is meant to solve a specific set of problems. It means future of application development is definitely heading towards something new which can be termed as hybrid solutions, where applications may decide to use multiple NoSQL technologies. Let's explore this with the help of an example of online shopping portal, where users' login credential needs to be stored into RDBMS. Online streaming of user behavior statistics into Cassandra or Edgebase. Product catalog or portal advertisement needs to be stored into MongoDB since they are documents. Similarly, server logs for batch processing and analytics is something which can be built using Hadoop. Faster in-memory cache or user session can be managed via Redis. and user's activity graph can be built using Neo4j.
Thank you, Vivek. Clearly, the demand for hybrid applications is growing. We've seen a lot of what is driving all of this. And users today will need to focus on specific technologies based on very specific requirements rather than looking to the RDBMS as a cross-enterprise, one-size-fits-all kind of a solution. So this whole specific technology for specific needs paradigm holds some great promise, is very appealing, and has resulted in the explosion of all these solutions and the growth of NoSQL. I'd like to ask Chavi, our other subject matter expert and an architect in our Impetus Labs organization, to jump on now and expand on that, analyze some of those challenges in some detail. Chavi, please.
Thanks, Larry. Let's take this discussion forward by understanding some of the inherent challenges that actually need to be addressed before implementing a system which is based on any hybrid design. So one of the biggest challenges that any organization may face today is in training its engineers to actually start using the new technology. These engineers are actually accustomed to using the old traditional RDBMS solutions itself. So that means that in order to enable the engineers to start building any such hybrid application, it might require a huge learning curve. And definitely, it is a cost to an organization. Also, it is quite obvious that not all your requirements can be fulfilled just by a primary key-based access. Search over non-primary key columns will definitely be needed at some point of time or another, no matter how much denormalized your data is. Another aspect to it can be applications, no matter how big or complex they are, they will definitely require to ensure the consistency and the guaranteed atomicity of the data. Let's understand this by an example here. Suppose a user is checking out a product and is about to make a payment. And just while storing the data across Cassandra and RDBMS, imagine if one of the server goes down, then what would happen? It will result in a partial transaction. Let's take a look at another problem or another thing that needs to be addressed. That is, what if an application requires handshaking or data migration among multiple data stores? What if the user wants to keep the backup or migrate the data to some other database? Again, as we all are aware that the NoSQL world is evolving and many new NoSQL databases are coming each day. So, since I have more options, a user would definitely might want to, switch the databases, depending on the kind of needs that it serves or the requirements it serves. And at the same time, any user would like to ensure that it will happen in the minimal cost. Again, there are many organizations that are looking for such NoSQL databases and the NoSQL technology solutions as an alternative to achieve scalability and performance. But they already have legacy applications that are built on the old technology stack. So, in order to migrate their applications to NoSQL, do they actually need to implement the complete solution afresh? A way out here can be to migrate the existing solution. But is that possible? Well, let's find out. So the main question here is that is there any master key or a master solution to unlock the multiple doors or to come up with the solution to all the earlier mentioned problems? Is there any solution that is available that can enable me to build a hybrid platform? Let's explore a little more to find out the answer to these questions. I'll start with taking an example of a user log storage system. Applications with large user base may have enormous amount of data logs. And these data logs are expected to grow huge in size, say up to multi-zettabytes. Again, as we discussed earlier, that the RDBMS systems are not designed to support such large volumes of data. So in order to keep the scalability and performance of such applications as a high priority, the applications need to migrate the log data from RDBMS to a data store which can actually handle or which is designed to handle such large volumes of data. Again, this was the case with a famous online portal which eventually started using Cassandra to store the user logs, but however continued to keep the user-related information in RDBMS itself. Now, storing data in multiple data stores for one application and at the same time ensuring the data availability as well as its atomicity. This is exactly what is called as polyglot persistence. So now, having understood the polyglot persistence, the next obvious question that arises is that how do I make or implement my application in a polyglot manner? Are there any available polyglot APIs, or do I need to write my own custom code for, say, each data store that I wish to use or I wish to integrate? And at the same time, there is a concern that how do I ensure the various other important aspects like atomicity, multi-data store persistence management, etc. Now, one solution available in the NoSQL space is Spring Data. However, an alternate to it can be Kundera. Kundera is a one-stop solution which offers you a wider range of choices, and it can be used over several data stores that it supports. We'll discuss that in the further slides. Now, Kundera is a JPA compliant solution which is very easy to learn, and it's already since it uses JPA, it is a popular specification, so it can be learned very easily. So what is Kundera basically? Let's find out. Kundera is a single high-level Java API which supports 8 data stores currently. The basic idea behind Kundera is to make working with NoSQL databases drop-dead simple and fun. Well, it makes working with NoSQL as simple as working with any other SQL. It serves as a JPA-compliant mapping solution for NoSQL data stores. Not only this, it helps the developers to forget the complexity of learning or understanding NoSQL data stores and keep completely focused on the domain model. Again, additionally, it also enables the switching of data stores as easy and as simple as just changing a configuration. To list down a few key features that Kundera provides, it has a robust query system. It provides you easy object-to-relational mapping. It has support for secondary-level caching, event-based data handling, connection pooling, as well as Lucene-based indexing. So in the next few slides, we'll take a quick look at the code to demonstrate how simple and easy it is to start using Kundera in your applications. So the first thing to do to start using it is to download and add it to your project. Again, as mentioned earlier, Kundera is a JPA2 compliant solution. And so in order to start using it, all you need to do is to define your entities corresponding to your data schema just in JPA way, as you can see it on the screen. They're the simple JPA annotated entities. Again, once you define your JPA annotated entities, the next thing you wish to do is to specify the configuration files. In these configurations, you just mention which data store you want to keep which object in, and the several other important configurations, and the 3 lines of code, and you're done. That's it. Another thing that, as we discussed earlier, a user may have another requirement is to switch between the different data stores. So with Kundera, what? Do you need to kind of take care of all the problems that I discussed earlier? No. Here on the screen, as you can see, that you just need to specify it in your configuration file, that which data store again corresponds to which data, and the same 3 lines of code, and you are able to achieve the switching simply. That's it.
Thank you, Chavi. That was excellent. One of the questions that may be on the mind of some of our audience is, does Kundera affect the performance or increase latency by adding another level of abstraction? And we have benchmarked that in our lab, benchmarking Kundera against the different native libraries that it's used on. Yahoo's YCSB framework was used for measuring that throughput. And it shows the following, which you see depicted here on this graph. And the range of impact using Kundera was in the 3 to 6%. And that's 3 to 6% of what typically are some very low latency response times anyway. And so that was not deemed to be significant, but there was that slight amount of overhead. This happens to show the relationship to Cassandra, but it tracks with similar results that we have seen with some of the other data stores that we benchmarked. And when you weigh these numbers against the ease of use that Kundera offers to handle the issue of polyglot persistence and ensure that issues like transaction management, atomicity, and data migration, frankly, are small trade-offs given the challenges that it addresses. To summarize those challenges, after discussing Kundera and how it addresses those issues, let's just revisit that for a minute here in summary. If you look first at index-based retrieval over multiple NoSQL databases, big feature, we talked about that. You simply plug in a Kundera-powered ES or Lucene you can plug in a Kundera-powered ES or Lucene indexer into your application, or you can build your own library and plugins using Kundera. The second would be to unlearn what we're used to and learn new APIs. And because it's based on the most popular JPA 2.0 specification, it's easy to learn, simple to use, allows us to address atomicity, guarantee of maintaining atomicity and transaction management because it has built-in support for JPA and JTA transaction and batch operations. And the NoSQL world is evolving. What if I start out on one NoSQL solution and I want to switch to a different data store later because a new one came along that's a better fit for my requirements or any other variety of users or any other variety of reasons? And since it's a JPA-powered solution, you can actually reuse the same code with almost no changes. So that brings us to the end of our discussion today on this topic. And what we've seen is that it is possible to address the polyglot requirements of a variety of use cases across many different industries, that there are APIs available to handle that. And Impetus Kundera is one such solid JPA compliant way, and it has been open sourced, so it's available to all of you at no cost, and it's already being used in production at many large organizations. So thank you for being with us here for this recorded version. We do have some questions that came in during the webinar, and we'd like to now close the event by looking at some of those, and I'll take those one at a time and ask our experts to jump in and offer a response to that, and then we've got another summary slide which will show you how to order that ebook. So let's look at some of the questions that came in. The first was talking about polyglot persistence. We can store records in an atomic way. Is it possible to read them back in a single query? And if I could ask one of our architects to jump in and answer that, thank you.
Yes, this is something which is possible with JPQL queries. Depending upon defined fetching strategy, user may retrieve data from associated entities in a single query.
Okay, great. Thank you. The next question asked about is it possible to achieve consistency, high availability, and partition tolerance? We talked that is possible. Can you share some examples to support that?
Yes, let's discuss this with an example of Cassandra. So Cassandra's peer-to-peer architecture ensures high availability and partition tolerance along with eventual consistency. So with Cassandra, we can set consistency level per operation. So this is possible to achieve high availability, partition tolerance with eventual consistency.
Great. Thank you, Vivek. And we did state that Kundera is open source. How many people are using Kundera in production today?
Yeah, it's a very valid question. So to answer this, as far as I know, there are around 12 to 15 known Kundera-powered production applications. And actually, the few ones which actually being allowed by vendors themselves to publicly publish them are available on our GitHub website. So on github.com, production deployment over Kundera GitHub, we can go through and for that list.
Okay, great. And the last question that will take time to answer here, again, came in from our audience. If I have the same data in different NoSQL data stores, how do you handle conflicting values?
Right. So Kundera, being an object mapper API, it provides a way to map entity objects to data on Datastore. About conflicting values, so I think a programmer needs to take care of column value mapping with data stores for the one with the latest values.
Great, thank you, and thank you to our audience. What you'll see here now are a couple of different opportunities for you to get your additional questions answered. You can write to us at bigdata@impetus.com if you have questions about anything that was done today, or if you would like a free copy of Vivek Mishra's ebook entitled Apache Cassandra for Developers Starter. We mentioned getting started with Kundera. It is open source. You see the address here, the GitHub location where that can be downloaded, and would encourage you to try it. Lastly, we are exhibiting and sponsoring at a number of important big data events. You see the list of those here. If any of those are in your area or you're planning to attend, we certainly would invite you to stop by and would love to meet you personally. Thank you again for being with us today, and this concludes our webinar.